Now it's full screen. Thank you.
Perfect. Okay, thank you. So good morning and good afternoon and maybe good evening to some of you. Wait, can you still see my screen, Elaine? Yeah, okay. So I'm going to talk about some controversial points maybe, but don't get me wrong, I love biogas projects. There's just some things that we need to point out. So the main question is the implementation of biogas technologies always climate friendly and do no harm? So in theory, the anaerobic treatment is less energy intensive. You have biogas production that you can use for energy recovery. And it consumes also less energy from the traditional sources. And if you have energy recovery, then you consume even less energy from the traditional sources. And then you have an emissions reduction, mitigation. And so in climate-friendly projects, the common thought is that it's always that the anaerobic treatment with biogas recovery is better for the environment than the aerobic treatment. And when you talk about wastewater treatment, you need to consider if the project is going to be implemented fully and well operated. But yes, of course, for wastewater treatment, the anaerobic treatment systems, they have a large applicability. They have several favorable characteristics as low cost, low solids production, and operational simplicity. And also the environmental conditions in Latin America and other warm climate countries, they are favorable to anaerobic digestion. So this is an option that we should consider, especially in these countries, to apply this kind of technology. But if you think about the biogas, projects, or therefore anaerobic treatment systems that use the biogas being produced, then this step is not so, the operational simplicity, it's not that simple anymore. So this is something that we need to consider. But if in projects well operated, we calculated some scenarios, and yes, usually the projects with biogas recovery, with energy recovery, are more climate friendly and also more profitable than a project that doesn't use the biogas. So we did some scenarios with different kind of treatment technologies. For example, the scenario with activated sludge plus sludge digester. A project with 100 inhabitants with the use of biogas is circa 7% more profitable than a project that didn't use the biogas. This considering all the investment costs and operational costs for the biogas treatment implementation, the CHP implementation, and all the energy recovery parts. So it is even so more climate friendly, and it's also 7% more profitable because of the energy being produced. In another scenario, with USB reactors that are really common in Brazil, especially this configuration, USB reactors plus as first step and then activated sludge, then it was, using the biogas was 9% more profitable. But then if we consider two different technologies, for example, USB plus activated sludge versus extended aeration activated sludge. Then, of course, extended aeration, it's very energy intensive. So it was, using the biogas was 40% more profitable. But then this is all considering that the anaerobic part is well implemented, well operated, that all the biogas is being collected and transformed into energy. But if we consider a USB reactor, for example, that is really common in Brazil, or even anaerobic lagoons that are really common in Latin America, badly operated or not well sealed. We have some problems with the covers from the anaerobic lagoons. So versus an aerobic treatment, then the CO2 equivalent emissions are higher than the CO2 equivalent emissions from the energy consumption from the aerobic treatment. So this is something we need to consider, because sometimes, and of course, the main goal from the wastewater treatment company is to treat wastewater. So, but sometimes they look at the whole project and then, oh, in the future you can use the biogas, so let's implement this, or we're going to collect all the biogas and at least flare the biogas, burn it. But then, due to the money available or other conditions, they focus on the water part, on the wastewater part. They implement the project and don't really have the concern with the gas part. So you don't really, the systems are not well sealed. You have lots of leakages to the atmosphere. You don't really flare the biogas efficiently. And so you have this CO2, the methane emissions, no? And then if you convert it to CO2, much higher than if you'd have implemented just an aerobic treatment. So this is something, these scenarios we need to consider. And also, we did a little bit of research of why the biogas, especially in USB reactors, was not as much as we thought, and why we had so much biogas losses in these systems. Because in Brazil it's really, really common, and it started, well, lots of people started to say, oh, okay, so you already produce biogas in the USB reactors in lots of wastewater treatment plants. So the potential for biogas projects, for energy recovery projects, is really high in Brazil. And then, but it's not always feasible. And what we found out is that they don't produce or collect the amount of biogas that they should in theory for the organic matter conversion. So let me just pass this slide. So we found some problems in these reactors. I'm not going to get into all of them, but scum accumulation, and then the biogas could not get through, or lots of leakages, as I said, systems were not well sealed. So you had the emissions and other emission as well. And also you need to consider the methane, that it's dissolved in the liquid part. So all of that caused that the biogas being collected was not as high as we expected. And we found that out also in the Pro-Biogas project from Gaiazet here in Brazil. So we measured the biogas production in 10 wastewater treatment plants. I'm going to show it quickly. We basically measured all of it, the wastewater flow rate, the COD in the income and outcome, the biogas flow rate, the biogas composition, and then if we compare it with the scenarios, we have it here. We have it here, the best scenario that considers some leakages and some methane dissolved, but OSB well operated. And if you compare it, none of the stations, none of the plants reached the best scenario. That's usually the scenario you would consider for a new wastewater treatment plant and for considering energy recovery project. And then some of them were in between the typical scenario and the worst scenario. And there are some other plants that are not here, but they were even below the worst scenario, where you consider the system's not sealed and lots of leakages and losses, biogas losses. So that's why we recommend to measure the actual biogas being collected and to implement some improvements in order to being able to collect more biogas. So we can talk more about this later, but I would also like to talk about, yes, in USB reactors, you have lots of variables and it's harder to determine the biogas production, but usually the biogas being collected, it's not as high as you would expect in theory. So you have to consider all these losses and always, when it's possible, you should measure it. That's really important. And even with plants with the same size, we found out like one plant was in the typical scenario and another plant was even below the worst scenario. So this can influence a lot on your business model. But also, okay, USB reactors are a bit more difficult, but also I would like to talk about the sludge digesters because they are a bit easier. The technologies, you don't have so much leakage in them, but still you can have some problems when they are implemented in countries that don't have this knowledge well spread. And so that's what we found in Cusco, for example. The biogas flow was much lower than what expected. And this is what happens also. It was really hard to find the answers and the operators to know what was going on and what was the problem, that the biogas flow was so much lower. And when you don't really have, oh, okay, I'll ask the wastewater treatment plant next to me that has the same system and maybe they can help me. When you don't have that, it's much harder to find that out. And that's why it's also really important, the example that Bentley gave about the learning networks. So this exchange of experiences of well-implemented projects, it's also really important. And then we found that biogas flow was much lower due to a number of reasons. One of them was inefficient mixing. Another one was the position of the sludge circulation pipes. And the heating was not properly distributed as well. So these are some of the reasons. But at the end, what we can conclude is independent from the technology, you can talk about digesters or USB reactors or anaerobic lagoons. Some of the lessons learned are the same. That is, for existing wastewater treatment plants, it is really important to measure the collected biogas. It's not, as I said, usually it's much lower than what you would expect from just applying that simple equation from theory, from the book. And then you choose your engine according to the actual biogas being measured. And then you define your business model because this influences a lot. And you also need to consider ensure effective operation to avoid these unscheduled motor shutdowns. As Christoph said, one simple pump in this project in Bahia caused 1 month of motor shutdown unscheduled, and even more actually. But and it is why it's also really important to choose a procurement procedure that predicts these difficulties because you need specialized operation. the utility, the wastewater utility, is specialized in wastewater treatment and not in gas treatment, or especially in energy recovery. So you have lots of difficulties. You don't have the spare parts there. They needed to define a procurement procedure, and it's really bureaucratic. It's really hard to get that through. And also, we think that performance contracts should be an alternative for the agility of the process, because then the wastewater treatment company can focus on the wastewater treatment, and the specialized company can focus on the energy production, on getting as much energy as they can. And then if they don't run the engine, if they don't have the spare parts quickly enough, it's basically their loss, because they're losing money with it. So, and it is usually a private company that have more agility to the process. So this is something that in some cases could help, at least now in the beginning. And I love to talk about this topic. I'm looking forward for the discussion. We can discuss more about all of these examples that I talked about in the discussion. And I hope to see soon lots and lots more of projects in Latin America and in other countries. And I'm looking forward to hear also Karsten to talk about Costa Rica. So thank you very much. I'm looking forward for the discussion. Thank you.
Thank you so much for your presentation, Carolina.